So let's talk about how you can have potential energy from an object's condition. We just talked about position. You can put an object high, or you can stretch or force it beyond its normal position, and that'll give it energy stored in there because of the work that you did to get it there. But also, objects, just because of the way they're made, they can also have potential energy. Good example is a battery. Batteries have an acid paste in them. The electrons in that material flow really easily. They're easily pulled out one end of the battery through a circuit and drawn into the other end. Another example is gasoline. The way the atoms in gasoline are, the energy holding them together, can be easily released if you heat the gasoline up and catch it on fire. Even the food you eat. Anytime you eat food, the atoms are held together by energy. Your body digests that food and uses that as a source of power to keep your body running. You might have seen this before. Coal. What is coal made of? Yes, even though it doesn't look like it, coal is actually millions of years of fossilized dead plants. And you know that plants make their own food. When a plant dies, the food that's still in it, the energy that's there, it gets stored there. And so when you have a piece of coal, you have millions of years worth of dead plants. You heat coal up, you can release the energy that's stored in it. And then also, you may remember at the beginning of the year when we were studying atoms, one of the things we learned was that in the nucleus of an atom, there's energy holding the protons and neutrons together. We even talked about how when scientists discovered that force holding them together, we made fun of that name, strong force. It's so powerful it's enough to supply electricity for entire towns or even build a bomb. So really, every piece of matter probably has some amount of potential energy just because they all have a nucleus and those particles are held together by that strong force. So let's make our notes catch up with this idea. So on the condition side, let's write. When we say an object has potential energy because of its condition, we're talking about its atoms. Either the energy that's holding them together, those bonds, you break them apart, you can use that energy, or the energy that's inside the nucleus of that atom. The protons and neutrons and uranium are held together with that strong force. We split the nucleus, we can use that energy. Examples of this would be gasoline, a battery, or even the food we eat. So let's review. You can have potential energy either by an object's position or its condition. Position can be because of height. Put it high up, gravity can pull it down. And the higher you put it, the more potential energy is stored there. Or the more mass the object has, that also gives it more potential energy. You can also take an object and force it beyond its normal position. We call this elasticity. A bow and arrow or a spring is a good example of this. And then the other way is from an object's condition, the way it's made, its atoms. Either the energy that's holding the atoms of a compound together, or the energy that's stored inside the nucleus of each atom. That strong force also is a ton of potential energy. Examples could be like gasoline or a battery or food. Now, on the next clean page, let's talk about kinetic energy. We're not going to write as much about it, and it's much easier to recognize. So we said potential energy is stored energy, but once you start using that energy, we don't call it potential anymore. We call it kinetic. Write this down. Now, the next two bullets are going to be definitions, quick definitions of kinetic energy. One way to think of it is just energy in motion. You can always tell if the energy is kinetic because, remember, energy is the ability to do work, and work only happens if something moves. So if something's moving, you know that that's kinetic energy. That's the state the energy is in. Another way to think of it is energy that's being used. Now, let's look at this example. See here, I can't even talk. See here, you can see we have a bicyclist who's bicycling up a hill and then pauses at the top of the hill and then goes down the other side. So as the cyclist is going up the hill, he's moving. So we would say that that's kinetic energy. If he gets up here and then he stops, He has potential energy, but notice this, it's not because he stopped. The potential energy is for a very specific reason. One of the ways he has potential energy that he can move now is because of gravity. He's up high, so even if he doesn't pedal, he can still roll down the hill. But also, he has potential energy because he ate food at some point, and now there's energy stored in his body. So he has potential energy from condition. Now, notice these other two spots here, as he's going up the hill or coming down. For sure that's kinetic, because he's moving. But, does he also have potential energy? If you answered yes, you're right. He has potential energy still because he's not at the bottom of the hill. He's up higher than he was before, so even if he stops pedaling, he has potential to just roll backwards because of gravity. In real life, usually we have potential and kinetic going on. Now, you don't have to write this part, but I just want you to think about it. So what's happening in real life is we have potential energy, stored energy, that gets converted or changed to kinetic energy, energy that's being used. It's putting something into motion. Now, I've got a couple of things I want you to look at that's going to help you understand this even better. And the first one's an animation. Now, when you look at this animation, it might seem confusing at first. I'm going to tell you what things I want you to notice. First of all, notice we have a ball that's rolling down a hill. And then on the left, we have 2 meters. The blue one is showing the change in potential energy. The red one is showing the change in kinetic energy, energy in motion. I want you to notice the blue one first. Look and see where the ball is on its path when the potential energy is at its highest amount. Yes, it's at the top of the hill. And notice what potential energy does as the ball travels down the hill. It decreases. Now let's look at the kinetic one. Where on the path is kinetic energy the highest? Yes, just before it gets to the bottom of that hill. Notice that as it goes down the hill, it picks up speed, it picks up motion. And so kinetic energy increases just before it hits the bottom. Now, if you've ridden a roller coaster, you know this, that as you come off that tall hill, right before you get to the bottom, you are really moving.